Bam. Good. Not detecting any input. Can everyone hear me? Can anyone hear, or can everyone hear me? Okay. All right. Cool. Cool. All right. Yeah. And for reference, I am using IntelliJ for today's lesson because I am still not quite used to Replit, but I hope that IntelliJ will still get the point across. So for today's lesson, we're going to be talking about abstract classes, interfaces, how to use those, as well as arrays and array lists to get everyone started on how to store larger sets of data. So right here, we have our package names, pack1, pack2, and inside we have bird, or we have our class bird. Now we can say that we want to narrow down our options because the bird class is relatively a broad term. Like there are no like birds out in real life. We just say that we have birds like robins, blue jays. If anyone has a favorite bird, they can tell me in the comments or questions. We can put ravens, right? The point is we have just these types of birds that we say have, or we have these different types of birds that we say are their own classes. But the advantage to having a bird class is that we can sort of consolidate dodos. Yeah, we'll make it a dodo because why not? Oh, and also a penguin because I believe that's going to be a pretty good example down the line today. Penguin. Right, so we have just these different types of birds that we have out in real life, but the key advantage to having something like a bird class is that we can say that we can sort of consolidate all these objects to be under one what's called a superclass. So we're gonna put right here that bird is going to be our superclass. Now, what superclass is going to do is pretty much we're going to be able to say that we'll say that bird raven is going to equal a new raven. Now, I can't do that right now because I haven't imported stuff. But we can't do that right now because see right here, we are providing a raven class where we should specify a bird. But we'll say key to having this bird class work is, remember before I said that having a bird class is rather broad because we don't have a generic bird out in real life. So we're going to have to deal with this keyword here called the abstract. Now what and this pairs off of the class keyword. Now what an abstract class is going to do is we can't initialize an object as itself. So if we go back to our main right here and we try to specify new bird is equal to new bird, that is going to be illegal in a sense because abstract is forbidding us from initializing a new bird object. Now just have that cleared up. Just give it an instantiation, not an initialization. So that's pretty much what abstract classes do right off the bat. Now we could have, from our last lesson, we said that we could have our constructors sort of like this. But if we can't provide a new bird, then how does this constructor get used? Well, that comes into play when we use the keyword extends right here, so that we say we extend bird. Now it doesn't do much right now because we haven't provided it with any sort of data that we need to give to any sort of bird. Now birds originally or already have, we'll say, a height. We'll give them a wingspan, stuff like that. And also from our last class, we say that we store this sort of data in private fields that we specify up here. We'll say int height and also wingspan. And then down here, last class, we also used the keyword this to specify that we want this data type height right here instead of using the parameter right here. So we'll specify this height is equal to the regular height, and that this wingspan is also equal to the given wingspan. Press a quotation there. So we can say that a bird already has some methods like fly, as well as we'll say eat. But for this case, we want to also make this method right here abstract. And what the abstract does for methods per se is that we don't execute the method inside the abstract class itself. Rather, we'll be what is known as overriding it. We'll say will be overridden in subclasses. So when we say that we want an abstract method, we're putting the abstract keyword right here and putting a semicolon where we originally or regularly would put curly braces. Now, when we say that we want to execute the fly method, we'll be going to the bird class to execute whatever we say in here. But in contrast, when we execute the eat method, we will be going to the subclasses to execute that method. Now, let me just extend bird to every single class right here so that we can get started with examples. Not Raven, we want bird. Now, IntelliJ is screaming at us because we need either to make Dodo abstract, which is not what we want to do here, or we need to implement the methods, which it's referring to the abstract method eat right here. So we'll just go ahead and do that. And right here, we say that we have, or we say it's not. We don't have it's not called a keyword right here. It's rather something else. I don't know what it's called, but what this does in Java is essentially just tell our compiler this is a sub method from what we're gathering from the bird class. Now IntelliJ is also still screaming at us because we need to provide the bird constructor on the inside right here with some essential data, the height and the wingspan of any given bird. Now going back to Dodo, we will still be saying that we have a public constructor Dodo that also takes in an int wingspan, or let's go down in order, int height, int wingspan, and instead of providing, we'll just, for example, instead of providing fields up here where we just initialize the information itself, we will instead be doing or giving this new keyword called super. Now what super is used for is telling our superclass, in this example being bird, that we are giving the information to the superclass so that its constructor will be initialized, so that we can think of super in this case as the bird, and then these parentheses for the parameter as the bird constructor in a sense. I'll just write that down. Think this as a new bird constructor. So that we'll specify that we want the height to go in here as well as a wingspan, so that the bird constructor will be satisfied. And so we can go ahead and I'll probably just comment that out. And then afterwards, after class, I will explain my reasoning further, so that we can go ahead and provide a public constructor for each class, as well as give an override method to fly. Int height and int wingspan. And then we'll just give that back or give that information back to the superclass, so that Java will no longer yell at us. And then you probably get the picture, so I don't have, actually, now that I think about it, we could probably give a Boolean exists, because we are given a dodo for a bird. Say that, and then the process is the same regardless of the data type that we want to specify. Exists equals exists, and then back to our classes here, we'll have to give the same sort of information that we would like in each bird that we're specifying. And then I will be pretty much copying and pasting right here Does anyone have any questions while I do so? Public Robin. And then add exists. Oh, come on, give me the tab. All right, there we go. And then we can just copy paste the super into every single bird that we have. And then do the same for the override. All right, so now moving on to our overridden method here. What the override does if we have multiple subclasses for any given superclass is that we could specify multiple eat methods that are unique to each bird that we have right here. So we can all that the eat method specify right here is going to do uh, is tell us that the robin is already eating. And then for this method right here, that we will specify that this raven is eating, and then in the main method, we will see that these eat methods are going to be different from each other. Actually, no, not outside of the. So now we've seen that we can no longer, or that was an inner class. That will be something for later down the line. But given that we have an abstract class of bird, we can't just say that we want to initialize this bird. We'll just call it bird one since this is already going to be a raven. But we can specify it as a new raven. Specify that the our bird object is going to be of a raven subclass. And we're going to specify that this is 20 units in height, has a wingspan of 45 units, and we already know that ravens exist out in the wild. And we'll probably say that yes, bid bird 2 is a dodo, and I have no idea what type of measurements. We'll say that their wingspan is pretty small, I'd say. And so we'll say that a dodo, not raven, dodo doesn't exist. And of course, we have to do some importing because of we're taking classes from package one outside of this package and putting them into the main method. Now, what we can do, well, I didn't specify. For Dodo, we'll probably specify that no Dodo exists, therefore we cannot eat. Therefore, it cannot eat. Therefore, it cannot eat. So that we can specify right here that bird 1 will eat and bird 2 will also eat. And then we'll just go ahead and run that and see that we can tell the difference. It is IntelliJ, so it's probably just going to be a little bit slower. And then right here, we'll see that this raven is eating and that no dodo exists in nature, therefore it cannot eat. Now, what we can also do is in dodo, we can override the method that we already have, which is fly. Dodo public void fly. And then for this, we will just specify that since a dodo can't exist, it cannot fly. It cannot flew, it cannot fly. And from this, we see that we can override non-abstract classes. So regardless of what sort of method that you have, you can override it at any time in a subclass that we specify. Now from the main, if we talk about flying, we'll say that bird 1 and bird 2 will both start flying, or at least try to. We'll go ahead and see that the dodo cannot fly, but we specified nothing in the bird class fly method to tell us to fly. So right now we'll just say that this bird is flying, just to be a little bit generic and not to override the fly method in every class. So we'll just say that so that we can establish the difference between right here, so that we establish that dodos cannot fly, but other birds can, but a raven can. However, if we specify that we want a penguin thrown into the mix, we'll say that 30, 53, 35 in height, with a wingspan about 10, because penguin arms are pretty small compared to the body, and we know that penguins exist. If anyone's seen the movie Happy Feet, or just been to somewhere really cold. Now we can already say that a penguin eats. Penguin can eat, but the problem with what we want to do here is that problem we face here is a penguin flying. Now, I don't know if anyone's seen a penguin fly recently, but as it is in my knowledge, penguins don't fly, and that's where we'll introduce interfaces as our second sort of abstract or our second way of words. Our second way of abstraction. So in IntelliJ, we can specify that we want a class, or in interface, enums are something else. But for now, we'll just stick with our interface and we'll give it a name. Usually, you want to specify actions in our interfaces, and we'll go ahead with that. Now, what interfaces do is we can only specify two things in it. We can say that we want we'll just give an example, an int test variable. Totally forgot how these. Forgot how variables work in this. But for methods, we'll just specify a void fly. Now we don't put any sort of access modifiers right here because what interfaces do is they give to their variables and methods a public and static keywords, so that we could say that or to give context, what this will end up looking like to our compiler is a public static void fly method. Now, just like the abstract class, we say that, or we give a semicolon where we would usually give curly braces. So we'll just be giving that. And then for variables, we'll specify that we want a test variable and that this is equal to 57, just give it a random number. And so what this does is that we have our public and our static keywords, int, and give it and we will be giving it a value, because what this does for variables is it tacks on a final keyword. Now we'll talk about final keywords in a second. They pair nicely with the static keyword, but for now we'll just be removing that sort of example. Or actually, just comment it out so that I can explain it once class is over. But now that we have our interface right here that specifies which birds that we want to fly, right here we can say that we'll be getting rid of, or at least commenting out, our fly method. Now this is probably just going to give us a bunch of, doesn't have, can't resolve method sort of issues that Java detects right out the bat. And then we can make, and then what we can do is make another class that we can probably stick between our bird abstract class, and our actual bird classes. Now, if this isn't making much sense, don't hesitate to ask. Now we'll just say that we have the class flying bird, but just like bird, this is also an abstract class because we don't have like a generic flying bird. Now we'll say that this will extend bird, as well as have a constructor that will also take in the given information that we had from any given bird. And then plug that back into our superclass. That was probably dumb, but just remove the data types and then we'll be fine. And then what we do to get our interface to link up with our newly made abstract class is say that just like how abstract classes have extends to make superclasses or to establish super and subclass dependencies, we will be using the implements keyword to specify that we want to implement the flyable interface right here. And then so right here, we can say that we want to override our actually, could we just I don't think no, we don't want to put that right there. So we could all right. So for the just comment those out so that the birds that we know can fly, we can further say that we are extending the flying bird method. And so that we implement our fly method wherever we need to. So we know that a robin can fly as well as a dodo, but of course, dodos are extinct, and therefore they get a little bit of special treatment. And so that overwrite is fine. But for penguins, they still remain as birds, but not flying birds. And that can be reflected when we go ahead to try and start creating, we'll say, flying birds as opposed to regular birds. The difference being that the bird class doesn't know about the fly method that we get from the flyable interface. So any bird that we specify can't any bird that we specify from a given bird object can't recognize the fly method unless we do some we'll call it wizardry for now, but for right now, let's not let's not delete semicolons. But we'll just remove one of these and then say that we want a flying bird 4, and we'll say that we need to specify new raven. We'll say that this raven's a little different, so give it a height of 48, wingspan of about 39, and it also exists. But on the other hand, if we try to say that we want a flying bird, we'll say test penguin, because this is not going to be a permanent addition. get a height of 10, hide that. Also true. The problem with this is uh, penguin is just a bird and not a flying bird. Now, if we wanted to, we could say that it extends flying bird, but we all know that penguins just don't fly. Which is why we created the abstract class of flying bird, so that we can differentiate regular birds from just flying birds. I'll just comment this out so that I can specify later that this will not exist. And this, I will be transferring this code from IntelliJ to Replit, but just for lessons, I will be using IntelliJ. Actually, we'll bring back that fly method because we will be using that later. But we can say that for bird 4, we'll be using the fly method, and as well as down here, say bird 5 is equal to a dodo with the same parameters, and then we will be saying that bird 5 can fly, and then we will comment out for right now, but we will also be talking about how we can get bird 1 to fly as well. We'll be building right now and seeing that while we did not specify any sort of we didn't specify anything to output to the console for bird 4, we can see that dodos still can't fly. So back to our first bird being of the bird object, we can do something like this, where we have an if statement as well as our curly braces. And then up here, we can say that we will be using this new keyword. I understand I'm introducing a lot of keywords. I will be defining them in the code that I output to Replit. But for right now, if we can say that bird 1 is an instance of flying bird, yeah, it's always true. But for right now, that's what we want. We can do what is known. I think maybe Neil talked about wrapping or typecasting. Typecasting is what I'm looking for. But yeah, I think we want to specify a double parentheses right here and say that we want a flying bird right here. And this is yelling at me for some reason. Change that. Okay, yeah, it's just yelling at me for that reason. But we could also specify that system.out. We will be specifying that this bird can't or cannot fly. But in this case, it's always true, so we'll never be reaching this sort of statement. So to go down or to explain what's happening here, for our condition inside the if statement, we're seeing if bird 1 is an instance of flying bird. Now up here we're saying where bird one is a raven, and if we can, and if we when we see right here, the or no, it's a raven, and when we see right here, raven does extend flying bird. Where's my main? Does extend flying bird, so that this condition is true. Now going down to what we specify inside the condition, we're saying that bird one right here, we're taking our bird one object and then typecasting it to a flying bird, and then from that we're saying that our bird one is bird one is and this is the important part, temporarily, or is a temporary flying bird, so that we could execute the fly method out or get bird one to fly. I don't think I specified it. Dang it. Yeah, I didn't specify anything in there. So we'll go ahead and say, print out to console that this raven is flying, so that we could see that in our main. And then bird 4 and 5 are also ravens, and that bird 4 is also a raven, and bird 5 is a dodo. And then we see that bird 1 is flying, as well as bird 4, because we specified that we have something to execute in the fly method of our raven class. Any sort of questions so far? Well, I just tidy up the code right here. Okay, so for another example, we could also say that we want to try to get bird 3 to fly by trying to execute the same sort of method. If we try to specify that if bird 3 is also an instance of the flying bird abstract class, it's always going to be false, because our penguin class only extends bird and not flying bird. But that penguin doesn't extend flying bird, rather just bird. Okay, and then we could we'll just say in the crazy off chance that any penguin attempts to fly, it'll try to fly. Actually, this could be a good example of saying that this won't work. So instead of saying that we'll have this condition right here, we'll just try to get a penguin to fly. Oh wait, no, that was bird 1, and penguin is bird 3, I believe. Yeah. Okay. Okay, and so this appropriately gives us an exception, obviously at line 29, which is trying to get our penguin to fly. Trying to get penguin to fly. But of course, the problem with this is we only specify that penguin is a bird, not a flying bird, and so it doesn't have a fly method, no fly method in the penguin class. And so this is an example of what is known as runtime exceptions, as opposed to saying that we have a double, but we don't give it any sort of name. This is a compiler exception because once we try to run this, Java will just say, "Hey, you have an exception here because this double does not have a name." That's a compiler exception, and it won't run our code if we have that sort of problem in our code. But this trying to get our best thing about Java is exception system, in my opinion. I do agree because it definitely gives some it gives you some things that you can do with exceptions, like with try catches, but that will not be talked about in this lecture. Might be in next lecture. I have no idea. Trying to get penguin to fly. Will, just capitalize that. What are you doing today in Java? Right now we are talking about superclasses, subclasses, abstract classes, and interfaces. If you want me to explain those real quick, I can, but right now we're we're trying to get a penguin to fly. Will cause inheritance. Will cause a runtime exception. Runtime exception. Now, runtime exceptions, how they differentiate themselves from compiler exceptions is that we'll be running all this code up until we hit this, and when our compiler tries to look for a fly method inside the penguin class and doesn't find it, it will just give us our exception that we in this case gave a wrong typecast because a penguin doesn't extend from the flying bird, rather just the bird. And I will give definitions in notes and in my code once I go over them after class. But the next thing that I do want to talk about is we'll just go over to package 2 and specify a new main. And give this also a main method to run. What I want to talk about in here is arrays and array lists. Now, arrays are going to be a much simpler data type. But for example, we will say that we want an array of integers. We'll just say test ints. But instead of giving, say, just one number, we need to, that'll work. Okay. So we'll give 2 ways to initialize these test ints that we are, actually, I'll give this one We'll say that these are doubles. And test dubs is equal to, I need to stop pressing M and start pressing N. We'll just say that new double, and we have to specify a number in here, and this will be our this will be the size of the array, which we will specify to say that we want 10 doubles inside this array of doubles that we're talking about. Now, for the test integers up here, we can specify specific values up here. Say that we want 6, 15, negative 14, 207, so on and so forth. Now, while we specify that that this is of size 10, it's implied up here that this is of size 4 because we're specifying 4 distinct numbers inside our curly braces up here. And so what we can do with this is pretty much, for the basics, just say that we have a test int. And I don't know if Neil ever went over enhanced for loops, but we'll be going, right now we can go over those. And then we will just be, we'll be printing them out to console. Now, going over what the for each, I will say that this is a for each, but also called an enhanced for loop. Enhanced, I know how to spell, I swear. For loop. Are for each reference and copy based. Can you ask that in a different way? I'm not sure if I understand the question, but going over what this is doing, we have our for loop, but for each integer inside of our int array, we want to print out each test or each integer, so that if we run, is a test variable a reference or a copy? Oh, interesting. Call during class. No idea who it is. But that is a good question, and I'm not quite sure how to answer that. I'd probably have to look it up and probably answer it later. But if I had to go off of answering it right out the bat, I would probably say that int test is a copy, because we already have our integer specified inside the array, and the int test is pretty much saying, well, actually, we could replicate this in a regular for loop. So right out the bat, Micdor, I don't know how to pronounce your name, but we can say that given an int I is less than test, no, not test doubles, test integers dot length for each, yeah, for our arrays, we have this one piece of data that specifies the length of any given array that we have. And so we could just say I plus plus. And so what we'll be pretty much doing is we'll say that this also is an int test, and then specifying that we want test integers, and notice that we have our rectangular brackets right here, and then saying that we want the index at I. Now I is going to go through 0, 1, 2, and 3 so that we get every single index inside of our array, and then we want to s out test. Now these two loops pretty much do the same thing, except if you have this sort of for loop and not a for each loop, you'll probably IntelliJ will yell at you for that because you can just use a for each loop, and it's more or less easier to read. But if we take a look right here, these will pretty much just do the same thing. Now this is from our for each, and then this set is from our for loop. Any questions so far about arrays right now? And then for our doubles, we'll say we have a double test. And then for our test doubles, we want to s out test. And then if we run that, we'll get a bunch of pretty much zeros. Now, can anyone talk to me about what or why that is? All right, so for our test doubles, we are initializing an array of doubles of size 10, but we don't give any sort of values inside our indices. So if we wanted to say up here that test double at index, we'll say 4, is equal to 250.982. We can do that, and if we run it again, we'll see at our fifth index, not the fourth, our fifth index, 1, 2, 3, 4, 5, that our fifth index is 250.982. I'll specify right here that this is the fifth index in our array, not the fourth, because with coding we pretty much start with counting by 0, or counting at 0, and then incrementing on. Not fourth because we start at 0. Not 1. All right, so that is the basic functions or basic functionality for our arrays, initializing them, giving them values, and also being able to iterate through them. Now, if we let's say we want to, we could just undo that and then comment everything out, and then direct our subject towards using our bird example. Now, we'll say that we have a list of birds that we do not know which types they are right out the bat. So we'll say that we have a bird. We'll say we have a bird list. Bird list. If I could spell. And then right here, instead of saying that we want values, because we can't specify values if we have an object array as opposed to our primitive arrays, we need to specify new objects because we'll say that we have a test of a new array of type birds, and that we have we'll say 5. But down here, if we try to iterate tests, so we have for test of tests. If we try to s out the memory location of or the hash code, I believe it is. Yeah, it's the hash code of tests. Instead of saying that these are initialized to 0, these are initialized to null because that's because how objects work if we don't specify anything here is that they are initialized to the keyword null. Or no, not keyword, rather it's what null is. We'll just say everything is null inside here. Now what null is pretty much a memory location that cannot be accessed, is what I've been taught. We use it as if it's like our objects are initialized to nothing, but rather it's being initialized to this memory location that cannot be accessed, is how we just say that we initialize it to nothing. Memory location that we can't access. So that's for our that's how we specify, or that's why if we want to use our curly braces to initialize our bird array, we're just going to have to say that we give it a new raven on the inside of here, and we are going to have to specify measurements and whether it exists or not. But for now, the general idea is we want to initialize a new raven, we want a dodo, and a new robin because we haven't used that yet. Let's say that we have a pretty large raven, say 100 units of height, with a 130 wingspan, and yes, it does exist. And then right here, obviously, dodos don't exist. And then we'll say that a skeleton that we quote unquote found, 120, 75 units, and so on and so forth. And we'll just do a little bit of formatting right here for each bird that we are initializing inside of our array. And then we'll say that this robin is pretty small, 15, 13, but it does exist. And then the cool thing about what we can do with arrays / Arraylist, we'll get to Arraylist in after this, but if we run this through a for each loop, we'll say bird, lowercase bird, from bird list. We can using our using the keyword instance of, we'll say that if bird is an instance of, we'll say a raven. Then we'll print out the console that we found a raven. Found a raven on the list. And then else, we'll say just no. And for this, we pretty much understand what's going on here. And then as well as bird test. So we'll just remove that from subject for now, so that we can talk about or look at our instance of running through our list of birds. Yep. So in the order that we give our bird list new birds to store. We give them in order of raven, dodo, and robin, which is the exact order that we run through this list with our for each loop. The first time we take a look at the raven, it is indeed a raven because that's the first index of our list. And so we say that we found a raven in the list. And then once we hit the second bird, we go to dodo. It's not an instance of raven, so we say nope, as well as the third, which is a robin, not a raven. So it goes to nope. Okay, and then let's talk about Arraylist as our first data structure. Now, Arraylists are a very versatile, interesting, and overall just very well used data structure. And we'll get to talking about this after I set up the full initialization. Okay, so what happened? So from here, we're importing our array list from the utilities that Java already has. We need to specify that this is our second bird list because we already specified that we have a bird list. Fantastic. And so focusing on the array list. Now, what an array list does from an array versus an array list. Now, what arrays offer us is pretty much a way to just store a set size of objects inside, well, an array. So we can say that our bird list is of size 3, and it is size 3 and always size 3 unless we do some rearranging of or what's the word I'm looking for? Reinitialize it with a larger size. But if we don't do anything to it, this is always going to remain as a size of 3. And always size 3. What array lists offer us is that we can say that the size varies. And what I mean by that, should I say that, or should what I mean by that is that we could add a new, not capital, add a new bird. We'll say that we want another dodo. Same peripherals, 120 height, 75 wingspan, doesn't exist, so and so. What this does is it adds to an internal array that's say that we want index 0 to be a new dodo. It's adding to an internal list so that we can say that this is now size 1. Okay, so going back up here, we're saying that we are creating an object array list and then of type birds. Now what this is called is a generic, which is definitely something more advanced that will be taught more down the line. But for now, we're saying that we want an array list of birds. We have our name right here. And then we're saying, or we're initializing this new array list object. And then we're able to add a new dodo to our list. And we can add as many birds as we want. But the key word there is that we add birds and not will say anything else. Like we can't just say that we want to add a new value of 58.2 or anything like that. That because what this method is looking for is of type birds, but we're providing a double, which is problematic and will get us some compilation errors or compile errors. All right, any sort of question, any sorts of questions that we have so far, talking about the differences in arrays rather than arrays to array lists. Now, what I'm also going to do right here is set up for, we could specify that we want a size, and array lists content collections are update but never queried, which is fine. Now, array lists being objects, as opposed to arrays, they come with methods rather than saying that we have an initial value. So we specify size right here as opposed to saying that we want bird.length. We can compare the sizes, but as Java is telling us right here, this isn't a statement. It's just getting information and not doing anything with it. Well, this is a statement, but nothing is taking it in per se, or no one's using anything with it. So we'll just say that we want to S out each of them so that we get the sizes of each. And we'll just comment that out for now because we're talking about how array lists differ from arrays. Now we're seeing that the first bird list, which is an array, is of size 3 because we initialized 3 objects inside of it, a raven, dodo, and robin, whereas the array list, because we only added one new bird being a dodo, inside the second list, that the size is currently 1. And with the second bird list, we can continue adding, like I said, new bird objects, that being like ravens, dodos, any sort of bird that we've created a class for. But we can also say that we want to. We can also remove. We can also remove from the list. Now with these first two methods, we can either specify by object or specify by bird which one we want to delete. For now, we want to specify by index, saying that we want to delete the dodo that we created, so that we could say that, or we can take a look inside the size before and after we remove. All right, so right here we're specifying the first bird list, which is an array of length 3. Right here, we're saying that this is of size 1, given that we have a dodo. And then for after we add a raven, it's saying that we're of size 2. And then when we remove from index 0, we're back to size 1. Now, there are caveats that we have to be careful of here, because if we, let's say we want to remove at index 1 now, or anywhere above that, because our size at this point is 1. But as we remember that indexes start at 0 and count forward, but if we try to remove from index 1, we'll get an exception for index out of bounds, because index 1 is assuming that we have an array list of size 2, not 1. And so, yeah, we will just get an exception that way because we specified something outside of our size for the given array list. All right, any sort of questions with that? All right, not seeing any sorts of questions, but this is pretty much what I had to talk about today. Yeah,